Okay. I was wondering who wants to drive with like the slides. I only have a couple, but don't mind doing it.
Yeah, I'll
But
go. I'll start. That's okay.
okay, cool. Yeah,
Is
yeah,
that cool?
cool.
Yeah.
Yeah.
All right. Welcome to Tempo Community Call, April 2022, the magical year 2022. We got a pretty cool agenda coming up, and I will go ahead and present this if I can present now. Window. Ooh, man, I almost presented not in slideshow mode. Ruined all of the good announcements. Be embarrassing. All right. So 2022 April community call. We got a kind of a good agenda, I think, today. Pretty action-packed. 1.4 is coming out soon. I'd say like in a week or two, we'll cut 1.4. We're just kind of let it be stable for a little bit in our environments. We haven't seen any issues, but we're getting like a final bug fix or feature in while we're in the next week or so, I'd say. Marty's going to tell us all about Parquet. We've been investigating this format for months. We have made incredible progress. He's going to tell us what we're going to do with it next. And he's also going to talk through a roadmap. So for like the next 3 months and 6 months kind of vision for Tempo, where we're going with the project. Then we're going to, Coonrod's going to keep us updated on metrics generator. Particularly cool that that's in 1.4. So 1.4 is the first open source release of Tempo that has this new component. It's totally optional. If you do run it, you can generate metrics from your traces and send those to a Prometheus remote write endpoint. He'll walk us through some of the updates there. And then finally, we submitted a PR to our repo, which includes some like first looks at TraceQL. And we'll talk through some of our ideas there, what we're kind of going for, what our ideas are, I suppose, in the world of query languages for traces. And we'll finish up with the old Q&A. So you'd be welcome to ask any questions you want there. And like I said, don't feel like you are restricted to only talking to that time. Feel free to throw something in chat, whenever we're talking about it, and we can kind of answer your questions as we're flowing through it if that works better for you. Cool. So 1.4 exclamation point. Tempo 1.4 is, like I said, maybe like in a week or two, we're kind of talking internally about it. It's real close. We're definitely not going to put anything major in the next couple of weeks. We might have a final, I think we want to get some metrics documentation in there so it cuts nicely into our docs website, and when you have 1.4, you can see all the metrics stuff and maybe like one more small thing or two, but we're basically there. So I'd expect that in the next week or two. In particular, we have some improvements for search. We've added some hedging, request hedging, which is our favorite hammer to smash nails with Tempo. And it's a trick where we're going to basically repeat requests to our serverless endpoints when they tend to be a little bit slow. And there was some query or search config movement. So if you have put some search in there, or if you've done some configuration regarding search, then there might be some changes. There might be some changes in the config. That'll all be in the release notes, of course. And we have a new object encoding. It's going to require a special rollout, and we'll detail all this in the release notes as well. But basically, you roll all your ingesters first and then your distributors. But it's a more efficient encoding it actually fixes a bug with our min-max time ranges on our blocks. And it will also just help speed up search a little bit, the current version of search. Metrics generator is making its first appearance in 1.4. I think that's the big major feature. That's the headline piece of 1.4. So if you're running Tempo, I think I'd encourage you to experiment with this. Like I said, it's totally optional, but it does generate some really cool metrics. And Grafana UI also has support for the service graph metrics. So you can make some nice service graphs, and we have some ideas, I think, to improve that in the future as well. And then we've also Tempo, one of the things it kind of struggles with is when it has enormous traces, like in the close to 100 megs or more than that. It can components when they attempt to search. They're working their way through all the traces. They hit 100 meg trace, it can a component. Compaction suffered sometimes. So we've just kind of improved our support for this already existing configuration option, enforced it in more places than just ingestion, basically. And the complete changelog will, of course, be available with the release notes. There's tons of small improvements and bug fixes and all kinds of normal things. So look forward to that. I'd say, yeah, like maybe a week or two from today. With that, I'll give it to, I think Marty's next. Is that right? Marty, do you want me to just keep on clicking, or do you want to click?
Actually, I wanted to add one more thing for 1.4. So there are some compaction improvements. So if you have really large traces, like 100,000 or more spans, that was in here. And I think like Gabriel, I think we worked with like Tanner for some of that. So maybe that would be interesting to you, like useful too. Cool. Yeah, next slide, I guess. What is the next slide? Boom. All right. We're really excited about Parquet. This slide doesn't really cover our excitement. It's a lot bigger than this. But basically, columns awesome, rows are bad.
It needs more exclamation points, Marty. I'm disappointed there are 0 exclamation points on this live.
Yeah, you're right. For the next community call, we'll get that for sure. So we actually dug really deep on this in the last community call. I didn't put all of this in here again, but we kind of went into the schema, the approach, like what are the reasons, some of the benchmarks that we've seen and things like that. And since then, we've just been digging into it and really crossing off any blockers that are out there, and we've been writing up the code. So yeah, so we're feeling really good about this approach, and it's something we're gonna invest in heavily. And so yeah. So with that, so we can kind of talk about maybe the roadmap. That's the next slide, and how this plays into it. So this is something we've kind of shown on and off in it for the past couple of months about search. Like, what does tempo search look like? What is the roadmap? Oh, we're missing an arrow or a line here that shows where we are, where tempo 1.4 is. Where did that go?
We are missing a line. Did we lose it
Uh-oh.
somehow?
Maybe you have to click again, like it shows up after a while.
Whoa. Was there an
What?
animation?
Okay.
Ooh.
All right, cool.
It's fancy. We just didn't know.
The slides are too complicated for us. So we, in the past couple of releases, like we've steadily progressed along this roadmap. Tempo 1.4, which is coming out really soon, is kind of here at the end of phase 2. So it includes the backend search and the serverless features and things like that. And then also we'll hear more about it, the TraceQL query language that has been in progress. There's the pull request out there now. And what it looks like for the next phases. So an implementation of TraceQL, more UI that we want to add along with it, and things like that. And so kind of what happened here is we added in the backend search, and we realized it wasn't just performant enough for what we really wanted. And so that's why we started kind of pausing and investigating real heavily into the block format. So we really felt like that was the bottleneck by having this highly compressed, kind of like basic protocol buffers just thrown into a block was just too heavyweight to go through. And so, yeah, we can go to the next slide and talk about where we're going after this. So this is a roadmap for the next 3 and 6 months. So metrics generator, will continue iterating on that. There's a lot of really good more ideas and cool things we want to do with that. And along with that, the features that are coming out of it and the data, so it drives more UI enhancements. So what we want to see for the tempo data source in Grafana UI is just a lot more usability and features, and I'm sure we'll go into that, and you'll see some of that later. And then TraceQL, the language definition, that's been happening, and it'll keep happening, and so that's out there, and you can look at that. We'll hear more about that. And so Parquet blocks, and this is where we see that going. So in order to really get search to where we want it to be, we want to try out this new block format. And so we'll start iterating that over the next couple of tempo releases, and then we'll probably do one release where it's marked experimental and then one where it's marked stable. And then, yeah, so there's a line here. So maybe we'll cut tempo 2.0 when that's ready. We're not sure. That's something we're talking about. It's a very big change to tempo. And so, yeah, that might be something really cool to look forward to. And there's a line all the way on the left that says we are here. It's a little bit hard to read, but yeah, that's basically today. Sorry, I missed that. Great. Cool. Yeah, so that is search overall and then tempo overall. And
I'd like to underline something Marty said where, you know, we built all this parallelization. We're trying to get search working on our existing blocks, and it was just too slow. And it's not what we want for tempo. It just wasn't at the level we wanted it at. So Marty has spent an enormous amount of time, Marty and Ananya both, digging into various new backend formats, and this Parquet format has just become more and more promising the more we've invested in it. So the big announcement here in particular is just we are 100% for sure moving into Parquet. And we're looking at like a 3 to 6 month time frame for an announcement there and for a release that includes support for it. The early benchmarks are extremely promising. Like any big tech switch, there's going to be there's going to be bumps. It's going to be, there's going to be some difficulties. But we're excited to move forward to this because we just think it is the best format to store this, multivariate, extremely high cardinality data with no restrictions, no cardinality issues or anything like that. Marty, do you have any good links there? Any good resources to share for Parquet?
Well, I think so. What I would do is, if you want to learn about Parquet just in general, I'm sure you could just Google that. I don't know of anything offhand, but there's a ton of it out there. Parquet's been around for a while. If about our specific format, so we kind of touched on some of that in the previous community call, but we'll also be pushing out a design proposal here soon, like maybe next week or the week after, about what our specific Parquet file format that we're going to go with. So those are the two things.
What was the name of the tech Parquet was based on? It was like a nested columnar schemaless
Yeah,
thing.
Dremel. Yeah,
Dremel.
so there's a white paper from Google called Dremel. Or at least that was the white paper. It was talking about the algorithm that drove Dremel, and more or less, and then so that kind of became Parquet. Yeah.
Okay. So that might be a good resource too for whoever's interested. If you want to kind of dig into what Parquet does, why we may have chosen it. It's a schemaless columnar format, which really matches up nicely with trace data, where you have some spans that have tags A and B and other spans that have tags C and D and every combination in between. So we think it's a really good matchup. And Dremel and I think Parquet are two great resources to be Googling or DuckDuckGoing or whatever you're into. Doesn't make a good verb, does it? Cool. Any other Parquet thoughts? We're going to move on, I think, to some metrics generator updates from Kunrad, if he's feeling up to it. If there's no other kind of ideas there. Cool. All right.
Yeah, we're good.
Do you want to present Kunrad, or do you want me to just kind of click when you say next slide?
I'll just say next slide.
Okay.
So yeah, I just wanted to share some updates about the metrics generator. Since the last community call, we didn't do any like major architectural changes, but we added some really nice features and a lot of improvements under the hood as we kind of been running this in our biggest cluster and just kind of figuring out what stuff works well. So if you're interested in the architecture, you can look at the previous community call, which has a lot more detail. So I just want to highlight some features now. Next slide. One thing we added, like we had this originally, then we removed it, now we added again, is exemplar support. So all the metrics we generate using the metrics generator will have exemplars pointing to traces that are stored in Tempo. So since we generate metrics from traces, we have this trace ID from the trace that's our source, right? And we can add that to the metrics. And what we'll do is we keep track of one trace ID per active series, and we write that to the backend, and then you can query it using Grafana or whatever tool you're using. So for example, this is a screenshot of service graphs. You can click on the request histogram for one of the metrics, and then the little like squares or dots are exemplars. You can click on them. So next slide shows kind of information you can see. So an exemplar has like a very specific value. So you can see the exact value of this metric, of like this data point in the metric. And there's a link to the trace ID. And on the next slide, you can also see the same for span metrics. So this is an example of using span metrics to show the latency of all the spans starting with HTTP GET of the Tempo query frontend. So these are the endpoints of the query frontend. So you can see them in time, and they're just like a bunch of exemplars, and you can click on them. So maybe you're looking for like a slow request, so you can look at the top of the graph, click on one of those, or you're looking for a fast request maybe, and then you can go like that. And on the next slide, I also have a screenshot. What happens if you click on one? You get the trace in a side panel. So you can click on an exemplar, see it, investigate a bit, and then pick another exemplar and go on like that. That's it for exemplars. You have to enable this in your time series database. Like it's a feature flag in Prometheus. And I think in Mimir you also have to enable exemplar storage, but yeah. Another nice feature we added is you can now add additional dimensions to your metrics. So service graphs and span metrics have a number of default labels they come with. So for service graphs, we always capture the client and the server. For span metrics, we always capture the service name, span status, and span kind. And that's like a good basic set. But sometimes you might want to add tags specific about your environment. For instance, you might have a namespace tag on your traces, or maybe you want to add additional information like the HTTP status. So we added a config option dimensions. And what the processor will do is it will look at every span, try to find this tag either in the resources attribute, the resource attributes, or in the span attributes. It will just look, everywhere for the span. And then if there's a value, it will add as a label to the metric. And we also do the conversion if there's a tag with a point in, a dot in, or some other illegal character for Prometheus labels, we will convert it into an underscore. So I think in the next slide, you can also see an example of that. Yeah, there's an example. Here I plotted the amount of span metrics, the amount of spans that were ingested, and I summed them by namespace. So this allows us to see how many spans Tempo ingested by namespace, which can be interesting if you have, for instance, multiple teams sending spans, sending traces. You might want to see how much is every team sending us, and then you can kind of make a breakdown. On the next slide, I showed the same, but with a histogram, I think. Yeah, there's an example of a specific span. So I'm looking for the P90 latency of the span HTTP GET, the Loki query range span. And I sum them by cluster. So you can compare performance of the same span across multiple clusters. And you can see this blue cluster is much faster for some reason. So maybe that's something you want to investigate. And then the next slide, I think, yeah, that's all for dimensions. So it's it can be very useful when you tune it to your environment. We're working on the docs as well, so you can already find the configuration for the metrics generator if you go to the latest version of the docs, which is kind of like the rolling release of the docs. It gets updated all the time. So we already have a description of the configurations. And we will also be adding a page about running the metrics generator to share kind of our operational experience, to share with which metrics to monitor, and how to configure the metric generator. So just to make sure, just to share our knowledge and help everyone out that tries to run this. And I think on the final slide, it's another cool announcement, I think, is we're currently working on rolling this out in Grafana Cloud Traces. So the goal there is that we generate metrics automatically for all the traces that are ingested by Grafana Cloud Traces. So if you enable this and you send us your traces, we will generate metrics and we will write them to the Grafana Cloud Metrics tenant of the same stack. So that means you don't have to run the agent anymore on your own environment to generate these metrics, because that can be very resource expensive. And it will just be easier, like the integration will just be done for you, right? The metrics we send will be built as regular active series, so they're not special in any way. They're the same metrics as if you would generate them yourself. But you save the hassle of having to generate them and spending the resource on that. That said, we're currently looking for beta testers. So if you're interested in this, if you're using Grafana Cloud Traces, you can reach out to us, just send a message on Slack or whatever. And we can enable this for your tenants. We're currently, especially looking for feedback to iterate on as we add more configuration options, more features and stuff like that. And that's kind of it for metrics generator.
Cool. I think metrics generator is kind of the big feature of 1.4. I'm excited to see it. I think 1.3 was search, 1.4 was metrics generator. Not sure what next will be, but we'll figure it out in the next couple of months. But yeah, all very neat stuff. The exemplars are really exciting. Me and Marty were just debugging some issue yesterday in which we, were looking at some metrics. We were able to use exemplars to jump to a trace, and we very quickly found that there was some kind of slowdown in an auth component in our cloud that was causing us to have slower queries than we wanted. And the ability to see the exemplar that was, outstanding, super high up on the graph, click on it and immediately jump to the trace and see why it was slow. I mean, it was like seconds instead of, digging through logs for whatever, 10, 15 minutes trying to figure out why a particular piece was slow.
Yep. Yeah, we're also working. So, for instance, span metrics has exemplars which allow you to go to a trace, but we're also working at integrating these metrics into the trace view. So, when you look at a trace, there will be in the future a button pointing to the metrics, so you can go from trace to a metric and then back to the trace and kind of like keep going until you find what you're looking for.
Cool.
There's a question: is it possible to generate metrics just for specific spans? So at this point, it's not possible. If you enable the processors for a specific tenant, we will process all the spans. So we don't have any filtering there. But we are thinking about adding filtering capabilities to, for instance, say, only generate metrics for spans that have a specific service name or maybe a specific tag to kind of allow you to know, if you know that some service just sends too many spans and the metrics are not interesting, you can just filter them out and decrease the amount of active series you generate. So yeah, we'll try to work on this like in the coming weeks and months. Yeah.
Cool.
Yeah.
Exciting stuff. Like to thank Kunrad and Mario, who's not on this call. They're kind of the smaller team, the sub team that's been putting tons of time into that. Like Kunrad said, if you're interested in participating in the beta, just at one of us in Slack, and then any questions, throw in our Slack channel. And I think either Kunrad or Mario are kind of the experts, but anyone would be welcome to help you out in terms of like configuring and getting this running once we've cut 1.4. Cool. So this seems like a pretty action-packed community call. TraceQL, Parquet is real. 1.4 is happening. But anyways, TraceQL, also another announcement, big announcement. Just, I guess, 2 days ago, we submitted this PR to Tempo, which is a design proposal for TraceQL, which is the query language we'll be using to query traces, to select traces or to find traces. Currently, we have a UI that's very simplistic. It does a good job. You can do duration searches. You can say this service name. You can pick service names. You can pick other tags. It has a pretty basic way of retrieving searches, but we believe that there's much more powerful ways to select and find traces, and that's kind of why we've put some time into this idea, TraceQL. So the design doc in particular is meant to be like exposing some of the core concepts of TraceQL. It's not really a complete language spec. We are working on that internally, but it's, I think, 13 to 14 pages right now and still in development. And I didn't think it was appropriate to just like brain dump that entire thing. It didn't feel like it would be very valuable to the community. So this is the core ideas and the core concepts. Please jump in and comment if you'd like, or add ideas or thoughts, criticisms. We'd like to spend some time with the community working out TraceQL, see if people like it, see what they dislike and like about it, so that we can take that and work it into the language spec before we really solidify the whole thing. So anyways, talk about some of the principles, some of the things we cared about in TraceQL while we were building it, and look at some examples here. The first thing is simplicity, and I think every query language at some level attempts to have some kind of simplicity, and we definitely want that in TraceQL. We just want it to be very easy to ask the most basic thing, and the most basic thing is just, please show me a trace that has this tag, or show me a trace that has this tag and is over 1 second long or something. And so we wanted to include this extremely basic way of just sitting down and typing your question. HTTP status is 500. Just show me any trace with that. I don't care. And then it will immediately start giving you results. So that top line there with the curly braces is kind of the official syntax. The curly brace specifies that you're selecting a set of spans. And the set of spans you're selecting are any spans where there is a tag HTTP status equal to the value 500. Directly below that, we kind of have this idea that maybe we want a shorthand. I think it's still up for discussion, But maybe we don't even want that. Maybe we want it so that there's a shorthand where if you just type in the most basic query with nothing, we'll just throw some curly braces around it for you and evaluate it. So again, the idea is we want simplicity here. It's important that we really just want you to be able to type the most basic idea. You want a user to just sit down and ask a basic question and get a trace or two back, or find some matching options, right? But this span set idea is very important. So it's really what the language is based around. We're going to be selecting sets of spans, and then we'll see in a second we're going to be passing those through a pipeline. But down below, you can see some more complicated examples. So in the first one, I'm ANDing two conditions. So only the spans that match both of these conditions will be like part of the span set that it is then that then controls the result set, the traces that are passed back. So for the first query there, for that first line where it says HTTP status equals 500 and service name equals app, both of those conditions would have to be true on the same span for that trace to kind of be included into my result set. And on the second one, I'm looking for both of those conditions to be true anywhere in a trace. So I'm going to collect all of the spans that where HTTP status is 500, and then all of the spans where service name is app, and then I'm going to and quote unquote these two sets together. So the second one will find any trace where both of those two things are true somewhere in the trace, and the first one of those two examples will find only traces where both of those are true on the same span. And this curly brace thing you'll see throughout, but this idea of span sets you'll see throughout. In fact, if you're familiar with logql from Loki, you're kind of passing log lines through a trace pipeline. In TraceQL, you're going to be passing a set of spans through a pipeline of filters and other kind of modifiers. We of course also want it to be powerful. I was kind of thinking about what to make these slides about, and I wrote simple and powerful, and I was laughing at myself because I think any language you ever see a presentation on, they'll probably say it's simple and powerful, but ours is too. So we want to be powerful as well. We want to be able to say complicated things, not just we want the basic thing to be basic, but we also want to be able to express more complex combinations of conditions, aggregations. We have this idea of grouping, and we've built it around like a pipeline, like I was saying. So on this very first line, we're going to be selecting span sets where HTTP status is 200. Then we're piping those into a count function. And then if the span set has a count greater than 3, it's passed through that filter basically. So that first line will find any trace where this tag, HTTP status is 200, is seen more than 3 times inside of that trace. The second one is going to do a very similar thing, but instead of counting, which is one kind of aggregation, right? We're going to do a different aggregation. We're going to average the duration. So I'm averaging the duration of all of these spans. If the average duration of the spans in a trace is where that particular attribute is true is greater than 1 second, then we're going to return that trace. So this would hopefully give power users more capability to express queries that are taking an aggregate information about their trace or asking more difficult questions about their trace. We also have this idea of grouping. So again, let's filter down to everything where this tag is true, only HTTP status 200. And then we're going to break that into we're going to break that span set down into multiple span sets grouped by namespace. And then we're going to count each of those. So that particular query will find any traces where HTTP status is 200 more than 3 times in one namespace. And of course, these tags are just arbitrary attributes on spans, and I'm saying namespace, but for you, maybe that is, NS or cluster or region or maybe some other tag. So these are not specific, special names. These are whatever attributes happen to exist on your tag. I'm sorry, on your spans. This pipeline idea is important, and what is passed through the pipeline is important. And what's passed through the pipeline is sets of spans. So we're filtering, we're finding a subset of spans, we're passing those, we're grouping them, and then we're going to do this kind of count filter on them, count to aggregate, and then filtering with that greater than 3. We also felt it was very important to ask structural questions about our traces. So this, we feel in particular, is lacking for any existing tracing solution that I'm aware of, where you can ask something about the way your trace is structured. A power user who knows the way their applications are architected, knows the structure of their traces roughly in the general sense, and they can craft very let's say, very detailed questions about their trace if they can ask questions about the structure. So a trace is normally a tree. That's not necessarily true, but it's normally a tree. And we've kind of approached it from that idea. So there's, first of all, this idea of like a parent. So I can ask a question about the parent of the current span with what is called like an intrinsic attribute on the span, which is, in this case, it's parent. So I'm saying parent.duration minus duration is greater than 500 milliseconds. So if there's a difference in the parent of the span and this span's duration, it's going to be caught by this filter. If it's greater than 500 milliseconds, I'm going to pass that along. Maybe I can use this kind of query to look for spanned differences where maybe there's like a network latency issue or something like that, because two spans have very wildly different durations. And then we also have the idea of a descendant operator, where you're going to say, I want to find traces where this one region is, or where region EU West 1 is a descendant of region EU West 0, somewhere in the trace. So somewhere in my trace, maybe like my root span, I have region EU West 0, and then somewhere down in a leaf or in one of the branches, I have region EU West 1 that would match this particular condition. And you would find traces that have this pattern where you're moving from one region to the other. So we're asking like structural questions about our traces. How is our trace structured? It's going to give you the power to find, ask very detailed questions about your traces and find really cool outliers that help you understand not what the core of your traces are doing, but really dig into the niche cases, the cases that tracing is powerful for, which is this unique trace. Why is this trace unique, and how can I correct an issue with it, or why was what's going on with it? Why is it different? So the primary ideas here again are this like span set idea, the pipelining idea, and then we also want to provide structural queries. So the PR that was submitted again has it has core concepts. It has a lot of what we just talked about here, and as well as some additional details. I really didn't get into all the details even in that PR. We're looking for comments, so please drop some in there, and please give us some guidance and help us build something that we think we would all want to use in this open source project tempo. Also, this is the first step for TraceQL. We do intend to start building things like metrics out of traces with this language. That's not included in the PR, but it is on our internal roadmap, our internal discussions, and our bigger design doc. We're moving into metrics from traces, and that's definitely going to be a part of this eventually. Cool. I think that's roughly it for our part of things. Appreciate everyone coming along. At this point, you're welcome to ask questions about anything that we've covered. We have some of the experts on here for all of the major pieces of tempo. So questions about 1.4, questions about Parquet or metrics generator or TraceQL are all welcome, or frankly, if you just want to ask anything about tempo, welcome to throw those in the chat if that's kind of the way you'd like to do it, or you can unmute and just ask whatever works for you.
Hey, that TraceQL like kind of overview is awesome. I hadn't seen that. I
just made it up like 50 seconds ago. Well, not that. I was here 50
great.
Seconds ago. I meant I made it up about an hour before this.
That's good.
Thanks. But yeah, go check out that PR. I think there's some exciting conversation in there already. There's some members of the community have already commented, and I would love to hear what anyone's thoughts on that are. Cool.
Is everybody here using tempo? Is anybody's clusters having issues? Everything is going great?
Of course, everything's going great. It's tempo.
Awesome.
Cool.
Yeah.
Same challenge as always. Extreme volume, is that your challenge, Gabriel?
Yeah, pretty much. I think the combined of extreme volume and single tenant is what we run into the most. But we have a good like feedback loop for tweaking. Compaction is the main thing, basically. I think the other pieces are working pretty well. There's one thing that I don't know if I mentioned last time, that we used to run search enabled, but not actually use it, just to like see how it would perform. And the CPU hit on ingesters and distributors was significant, and we had to turn it off.
Yeah, it
was like
does.
30%.
It does build like an additional data structure and pass that in between those components. I can't even remember what the cost was. We enabled it so long ago.
Yeah,
I mean, this is real vague, but I mean, our thoughts is that hit kind of goes away. Like as with the new block formats, maybe we don't have to build that extra data structure on the side. The reason we did that is because, again, the proto was just too costly to go through. So maybe, promising things there, hopefully.
Yeah, excited for 1.4. This all looks great.
Yeah, I'm not going to lie to you. Search as it exists would not have worked for your volume. It barely works for our volume, and I think we're roughly in line. You might be a little higher than even our largest clusters are. And so you needed Parquet anyway. So don't worry about turning search on. It wouldn't have bought you anything.
Great.
I think another cool thing that somebody requested that might be of interest to Gabe and that crew also is somebody asked about, and I've thought about this before, is providing time ranges for trace by ID search. Because at some point, the big bottleneck for query is you really search every block. It's a true key value store. If you've pushed this key at any point, this trace ID at any point in the last, however many days your attention is, it finds that trace ID. But a lot of times when you ask for a trace ID, you have some context. Like when we do our search, you'll have some context about when the trace was. If you're using a log format, like if you're using Loki or if you're using Elastic to do your searches, you have roughly the idea of when that trace hit. So if you just provide a time range, it's like 24 hours or something, you will drastically reduce the number of blocks you search and still get the trace. So that's proposed by somebody, and I think we might try to include that maybe in 1.5. On our side, the trick would be, of course, moving Grafana over to that and choosing when to do that. It's kind of a hard choice. Like, when do you provide a time range, and how do you find that time range? But at extreme scale, it would make trace by ID search faster as well.
That sounds good. Just because for our workflow, we have like a custom trace search thing anyways. And so through that, and that's done through a custom plugin in Grafana. So we have the time window where the trace was found, already. So it would be easy for us to like pass this on to then the trace lookup afterwards.
Cool. Well, that might be a 1.5 or 2.0 feature.
Nice.
We had a question here in the chat. Is search performance also optimized on 1.4 when not using serverless? Right. So for larger volumes, and I'm not sure what the actual cutoff would be, serverless is kind of required in order to just search that entire block space. I mean, even an hour, like at our volume, is a lot of data, way too much for just a few pods in Kubernetes to do. The optimization here in 1.4 is actually to basically store the trace timestamps like outside of the proto, so we can not deserialize the proto. So, and that makes it all the way from the ingester to the backend. So, I mean, there is an optimization even if you're not using serverless. But if you're not using serverless, the amount of backend searching you can do is already pretty limited, where this optimization is not going to be like a make or break kind of thing. So really, I guess it depends on your volume, like if we want to provide any more guidance there.
Right. There's no optimization when using serverless. It's just a matter of parallelization. Like serverless can provide thousands. You could technically scale your queries up to thousands and have the same impact. Well, I'm not sure what would happen to your query front ends if you scale up to thousands, but still, the idea is there, right? It's not doing anything special, anything different than the queries. It's just an opportunity to have massive scaling on demand, basically. And I mentioned the parallelization work and how it kind of came into 1.4. And I would like to say that all of that will be part of TraceQL, and all of that will be part of the new Parquet block format. None of that was throwaway. We were just building all of this parallelization around our current block formats. And even with massive parallelization, we still were not getting the speeds we wanted. So all of that will move forward into Parquet, and we will have these massive parallelization options along with the new block format for just where we think we'll be able to hit much higher ingest rates and much better speeds on search. We should add a way to choose the fields we want to display in the results beyond the metadata we share now, kind of like line format in Loki. Anyway, got to drop. See you all. Dropping that bomb and taking off on you? Sure, bud. So to talk about the results set, that is something that's important to us in TraceQL. So we talked about you're selecting a span set, which I think is kind of cool. So let's say you do HTTP status 200. What's going to come out of the end of that pipeline is sets of spans that match the query you typed in. And what my idea is, and we haven't sketched this out with Grafana yet, but the idea I have is let's display that in the results. So in the results, you'll see like a trace. Okay, this trace matched. It has some HTTP status 200s. And here's 2 or 3 of the spans that match. So I could deep link to the spans. So I can jump straight to the matching things. Or I can just click, the trace ID itself and kind of see the, and just go to the whole trace as one, go to the root basically. So I think passing this, or kind of the result set being sets of spans and using that, like the span sets being, or the pipeline being centered around span sets, I think is kind of cool because it's going to, I think, allow us to do cool deep linking into the traces from the results pane in Grafana. And I kind of am excited about seeing it, honestly. I think there's going to be some really neat features there. Something we struggle with at Grafana is huge traces because you'll have thousands and thousands or tens of thousands or hundreds of thousands of spans. It can be difficult to navigate. But if you type a query in and you very specifically pick a span and you can jump to that span, maybe that'll help with some of these larger trace issues. And then as far as custom fields, yeah, I don't know. Maybe. I'm not sure where you specify that. Maybe in the language, we could talk about that. I'm not sure how I feel about that. I don't know if I want the language to say what to display, but I don't know. We'll think about it. I don't know if anybody else has strong opinions there. Cool. Well, I suppose if there's no other questions, I'd like to thank you all for your time. It was another good community call. Expect some exciting announcements at ObservabilityCon coming up. I'm sorry, GrafanaCon is coming up in a couple months, and I think in June, and then ObservabilityCon this fall. We expect to have some really big announcements at those conferences. And of course, all the community call where you guys can keep updated. 1.4 is coming out. We have a Slack channel. Ping us in the Slack channel. Of course, file issues on the GitHub issue tracker. Or reach out to us. We have a community forum as well. Any of these avenues is great to get a hold of us. If you have any issues running Tempo, or you just have questions about the open source offering or whatever, please get a hold of us and let us know how you're doing. And then jump into maybe that TraceQL PR if you get a chance, and give us some ideas, thoughts, feedback on that. Thanks to everybody. Thanks to the community for using Tempo. It's awesome to see so many people here, and we are excited to keep working on this project. Thanks, Sheldon. All right. Take care, everybody.
All right. Great. Thank you. Bye.
Thank you.
Bye.